Hello, today I'll be working on this worksheet called Wave Basics, Sound, and Harmonics. I received this worksheet from my teacher, Miss Smit. So first of all, I want to talk about the basics. So, sound waves. A sound wave is a longitudinal wave created by some vibrating source. A standing wave has 2 points. The point that experiences no displacement, such as this point, because as you can see, it's right along this line. It has experienced no displacement. On the other hand, as you can see, the antinode, which is this point right here, has experienced a displacement. This is an amplitude. So an antinode is a point that experiences the largest displacement or the largest amplitude. Okay, so in the second example, letter B, you can see that this is the node. It's right here, right along the axis. It's experienced no displacement, while the antinode right here has experienced the largest amplitude. For letter C, you can see the antinode, antinode, antinode. They've all experienced an amplitude. And the nodes are here. They've experienced no displacement. They're just along the line along the axis. Resonance is a condition that exists when the frequency of a force applied to a system matches the natural frequency of vibration of the system. Natural frequency depends on the size, shape, and composition of the object. And harmonics are certain frequencies that can cause resonance and a standing wave. The longest wavelength and lowest frequency that can cause a standing wave is called the first harmonic. The first harmonic is also known as the fundamental frequency. The fundamental frequency is again the longest wavelength and lowest frequency that can still cause a standing wave. So we can easily answer number 1. It is the fundamental frequency. Any number harmonic frequency is just a multiple of the fundamental frequency. The first frequency is 320 Hz. This is just an example. The second frequency would then be 2 times the fundamental frequency, or the first harmonic. That would just be 640 Hz. And the third frequency is just 3 times the first frequency, which is 960 Hz. Now I'm going to give you the wave speed equation. You know, velocity equals to distance over time. We can translate this into wave speak. So the velocity would then be wavelength, which corresponds to distance. Wavelength is measured in meters, over the period, which is measured in seconds. Or you can just use velocity equals to wavelength times frequency. Okay, now we have open pipes and open closed pipes. So an open pipe is when both ends of the pipe are open, as you can see here. And this means that all harmonics are present. So really, harmonic 1, 2, 3, 4, and so on would be present, because both ends of the pipe are open. Open and open. Equation is wavelength equals to 2L over N. where n represents the harmonic number such as 1, 2, 3, or 4, L represents the length of the spring, and V represents the speed of the wave in the medium. On the other hand, an open-closed pipe is when one end of the pipe is open while the other one is closed. So as you can see here, this side would be closed while this side would be open. And the harmonic numbers that are present here are only odd. So really 1, 3, 5, 7, 9, and so on. The equation here would be wavelength equals to 4L over N. The frequency of any odd harmonic equals to N times V over 4L, where again N represents the harmonic number, which can only be odd in open-closed pipes, and L represents the length of the air column. So for number 2, a column of air in a cylindrical pipe that is open at both ends is capable of producing what? Well, if we go back, this is really saying open, open, so what does that mean? All harmonics are present. So we can go ahead and say both harmonics. Number 3, the term for the perceived frequency of a sound wave is called pitch. This is simply the definition of pitch. So if a column of air has two open ends, so open, open, and a fundamental frequency of 440 Hz, what are the first three possible harmonic numbers? Well, first of all, we know that we have F1, F2, and F3 because all harmonic numbers are allowed. Now let's find out the actual value for the frequency. So the first one, they tell us the fundamental frequency is 440. The fundamental frequency is the first frequency. The second one would just be 4 times 440, and the third one would just be 3 times 440. So really here we have 880 Hertz and 1320 Hertz. So number 5, if a column of air has one open and one closed, so closed open or open closed, which only means odd harmonics, and a fundamental frequency of 440, again, what are the first three? Well, first of all, we know that we have frequency 1, and then not 2, but 3 and 5. Okay? So for this one, what we have is 440 again, because this is the fundamental one. And then we would do 3 times 440 because of this number right here. This is the number, what number it is. So you do that. And this is 1320 Hertz. And then 5 would be 5 times 440 Hertz because this is really the fifth multiple of the fundamental frequency. Number 6, an open resistance tube sounds out a fifth harmonic, so number 5, at the frequency of the first harmonic is what? Any number frequency equals to the number, whatever number frequency it is, times the fundamental frequency. 100 Hertz equals to, we know it's the fifth harmonic, so times the fundamental frequency. Now we just solve for the fundamental frequency by dividing by 5. So it equals to exactly 320 Hertz. Number 7, doubling the frequency of a wave doubles the speed as well. So 2 times the frequency doubles the speed. This is not true at all. The speed of a wave remains constant as long as the medium is not changed. No matter what the frequency of a wave is in, for example, water, the speed will not change. Same for a block of wood. As long as the medium is the same, the speed will not change. I notice that the medium is the same. It's water. What does that mean? That means that, again, velocity will be constant. For the 440 hertz one, we know the velocity is still the same. We don't know the coefficient in front of the wavelength, and we know our frequency is 2 times the first one, or 2 times 220 equals to 440. This is why I've put the 2 in front of the frequency. So this is our equation, and because here I've doubled the frequency, in order to keep this constant, the velocity, we need to put something in front of the wavelength to make the coefficient of velocity equal to 1. Now, what is the reciprocal of 2? 1/2. So really, the length would be 1/2. Half the length of the former wave in order to keep the velocity constant. The frequency, we have the number harmonic. This is the number 1. We can assume that the frequency they give us is the fundamental frequency. We have the velocity. What we don't have is the length. We have this. We need to find the speed, and we have the length. So here we go. Let's just plug in the numbers. Remember, this is a different equation. Convert this to meters right away. To find meters, divide centimeters by 100, which gives us this value right here, and have the speed. Okay, so they want the fundamental frequency. We're actually looking for the first one, the first frequency, so we don't have that. We have the number 1, we have the speed, and we have the length. Number 4 is asking to determine the frequency of the 5th harmonic, so n equals to 5. When open is 5. We know our velocity. We know the length. So just plug in the numbers, and you should get 2000 hertz. Okay, so again, just remember that this one is talking about open-closed. So here I've included a picture of the open-closed pipe, and this is a node again, remember? And this would be antinode. Of sound, we know the frequency, and we know this. It's the number 1. We have to find the length. Now let's just plug in all of our values. I'm plugging in the number 1 because they told us that it's the first harmonic, which means that n equals to 1. Solving for L, we should get 1/4 of a meter. Okay, so for these ones, this is the second page of the worksheet. For these ones, I have figured out a great trick to get the answer every time. So I will give you the answer to the first one, and we'll work from there. Okay, so remember, open closed means only the odd numbers. Okay, so no even numbers. Okay, so we'll begin from here. This is a node, and we'll go over to here. Okay, so this is 1/4 of the wavelength, or 4 times the length. So now what I want to demonstrate here is how this is exactly 1. You see this? We'll count this as 1. From the node, or this axis right here, all the way to the top. So from the axis here, from the axis all the way to the top, we'll call this 1. Okay? Also, another thing I want you to notice is that all of these are going to be out of 4. 1 and 2 back down to the axis. However, we said this is 2. We can't have 2 harmonics. We need 3. So we get it back down to the other side from the axis again to the bottom. So from one maximum amplitude to the other. So we have 1, 2, 3. So then what you do is right away you see how many numbers you have? 1, 2, 3. You do 3 over 4. To get the other one, to get the length, you just do the inverse, which is 4 over 3. Now let's do the fifth one. Let's use the same method again. We do 1, 2, 3, 4. Remember, we can't have this because there's a node in the open side, and we can't have that. So what we do instead is go up 5. So now we have 1, 2, 3, 4, 5. So we do 5 out of 4. The inverse of that is 4 out of 5, or the length. Now 7 would be, this is a node. We'll do 1. This is an antinode. And node. We do 1, 2, 3, 4, 5, 6, 7. Okay? So we have 1, 2, 3, 4, 5, 6, and 7. So 7 out of 4, the inverse of that is 4 out of 7. And 9 would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is antinode. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 out of 4, or 4 out of 9. And this is how to draw it. Okay. So these are all in improper fractions. And just because I think that makes the most sense, and also helps you understand it. That you could also write these in another way, or draw these, sorry. The answers are the same, yet the drawing is a little bit different. For example, you would start from here and go down to the negative, so it'd be like this. But still we have 1, so again, 1 out of 4. Here it would be going this way, so go down 1, right? 1, 2, 3. So again, 1, 2, 3, 3 out of 4. Or we start here, be 1, 2, 3, 4, 5. Right? Okay. Color. So in this case, I will start from right up here. This is an antinode. And I will go 1. So from antinode to antinode. This I will call 1. So I want you to notice that here, all of these are going to be out of 2. Antinode to antinode is 1. So I'll do 1 out of 2. And the inverse of that is 2. And I will do now the second harmonic, which is 1, 2. This is 2 out of 2, or 1. The inverse of that is just 1. 3 would be 1, 2, 3, or 3 out of 2. The inverse of that is 2 out of 3. 4 would be 1, 2, 3, 4. 4 out of 2, or 2. The inverse of that is 1/2. And we do 1, 2, 3, 4, 5. Or 5 out of 2. The inverse of that is 2 out of 5. Now, I will do the other way. If you were to start here, yet the answers are still the same. We go 1 from antinode to antinode.